Hello, welcome for formative assessment. But before we go into formative assessment, we will answer question number 3 that we were doing in the practice questions of density. The question here reads, what is the volume of a sample of liquid mercury that has a mass of 76.2 grams, given that the density of the mercury is 13.6 milligram. So we are looking for volume this time, and this time we are not looking for mass, neither are we looking for density like in the first instance. So the first thing we will do, we will go back and create our triangle as usual, which will help to make our work easier. Then, so we said from this we have mass here, we have first density. So density is mass divided by volume, not the way the table is organized. So here it will be division, here it will be multiplication. So here we are looking, we will go now to our strategy. We will start by analyze. So we'll first analyze, and in analysis given, what are we given here? Mass. Given mass equal 76.2 gram, and density D equal 13.6 gram per milliliter. And the unknown, what is the unknown here? Unknown is the volume. The unknown is the volume. So in this case, we will be looking at trying to find the volume. So we will go to step number 2, plan. So we have to plan here, and from plan we have our normal formula: density is equal to mass over volume. What about if you want to find volume? So the unknown here is volume. So to find volume, we'll go direct to our magic triangle. So we want to find volume. So to find volume, we will take mass divided by density. Volume is equals to mass divided by density. So solve number 3. Solve. So to solve for density, we should solve for density. So directly we will go to solving. What was the mass here? 76.2 grams. And what was the density? 13.6 grams per milliliter. So if you have per ml, this ml, we will take it up and we will multiply it there. So we should multiply by milliliter in order to do away with milliliter. So, we are looking for volume. Sorry, I just made a mistake here. Oops. So this was volume. So if we are looking for volume, then volume should be in milliliter. If we take this, it will become a multiplication, so this we will do away with it. And we will cancel. What am I doing? Sorry for this inconvenience. This is gram. So I want us to do away with the grams. If we do away with the grams, so our answer now will be in milliliters, which is capacity, which is volume. So we will take the calc here, and into the calc we shall put our numbers. We have 76.2, and we are going to divide it by 13.6. Our answer will be 5.6. So we have 5.6 milliliter. So that is the answer, and that is the volume in this question. Now let's go to something else here. Conversion of factors. Now we are going to look at conversion of factors. So conversion, factor changes one unit to another. So we want to see what we mean here. So a conversion factor is a ratio derived from the equality. A conversion factor, a conversion factor is a ratio derived from the equality between two different units, derived from the equality between two different units that can be used to convert, to convert, that can be used to convert from one unit to the other. From one unit to the other. So it can be used to convert from one unit to the other. For example, suppose you want to know how many quarters there are in a certain number of dollars. To figure out the answer, you need to know how many quarters and dollars are related. So there are 4 quarters per dollar. There are 4 quarters. There are 4 quarters per dollar. And $1 for every quarter. And $1 for every quarter. $1 for every quarter. So there are 4 quarters per dollar and $1 for every quarters. So those facts can be expressed as ratios in 4 conversion factors. These can be those factors can be expressed as ratios can be expressed as ratios in 4 conversion factors. In 4 conversion factors. So we have here the first of the 4 is 4 quarters. 4 quarters divided by $1 is equal to 1. So we know that 4 quarters make $1. Then the second one is $1 divided by 4 quarters equal 1. The third is $0.25 over 1 quarter equal to 1. And lastly, 1 quarter, and lastly, 1 quarter divided by $0.25, this will also be equal to 1. So notice that each conversion factor equals 1. So that is because the two quantities divided in any conversion factor are equivalent to each other. Notice that each conversion factor equals to 1. And the reason for this is that two quantities divided in any conversion factor are equivalent to each other, as in this case, where 4 quarters equal $1. Where 4 quarters equal $1. 4 quarters equal $1. So because conversion factors are equal to 1, they can be multiplied by other factors in equations without changing the validity of the equations. You can use conversion factors to solve problems through dimensional analysis. So what is dimensional analysis? Dimensional analysis is a mathematical technique. Dimensional analysis is a mathematical technique, that allows you to use units to solve problems involving measurements. So when you want to use a conversion factor to change a unit in a problem, you can set up the problem in the following way. So let's see how you do it. When you want to use units, to solve problems, when you want to use the units, not to solve when you want to use conversion factor, when you want to use a conversion factor, to change a unit in a problem, you can set up the problem in the following way. You can set up the problem in the following way. quantity sort, so you take quantity sort, quantity sort equal quantity given multiply by conversion factor. Multiply by conversion factor. So for example, to determine the number of quarters in $12, you would carry out the unit conversion that allows you to change from dollar to quarters. So you would have here, you are having $12, you want to convert, so you would have number of quarters equal $12 multiplied by conversion factor. Multiply by conversion factor. So next, you need to decide which conversion factor gives you an answer in the desired unit. In this case, you have dollars and you want quarters. You have dollars and you want quarters. So to eliminate the dollars, you must divide the quantity by dollars. Therefore, the conversion factor in this case must have dollars in the denominator. In conversion factor, in this case, must, not this point here, must. So it must have dollars in the denominator. In the denominators, and quarters in the numerator. So in the numerator, you must have quarters, and in the denominator you will have quarters. So we will take 4 quarters. We will divide it by dollar. So which the dollar must be the denominator, because we want to convert the quarters. We want to do away with the dollars, so therefore it has to be in the denominator. Thus, you would set up the calculation as follows. So your calculation would be as follows. Quarters equal to $12 multiplied by conversion factor which is equal to $12 multiplied by the conversion factors here is this, by, so 4 quarters by 4 quarters divided by $1. So dollar and dollar will cross out. Normally the number 1 is below every whole number, so we would expect to have 1 here. So if you do this, you will remain with 12 multiplied by 4, which would give you 48, and this would be quarters. So the conversion factor has helped you to eliminate the dollar and therefore solve your problem. So notice that the dollars have divided out, leaving any answer in the desired unit quarters. So suppose you had guessed wrong and used $1. Let's say, for example, if you took $1, you just guessed wrong, then you took $1 divided by 4 quarters. So what would you have here? So you would have an answer with entirely inappropriate unit. Let's take the first example here. So this is what you would have. You would have quarters. You want to find quarters equal $12 multiplied by $1 divided by 4 quarters. So what would this one give you? So here, dollar and dollar would multiply, and therefore it would be squared. And this 4 here 1, 4 here 3, so we have 3 here. So 3 multiply 1, it would be $3 squared. Dollar squared over quarter. So basically your answer would be inappropriate. It wouldn't be the right answer. So it is always best to begin with an idea of the unit you will need in your final answer. So when working through sample problems, keep track of the units needed for the unknown quantity. So you have to keep track of the units of the unknown quantities. Then check your final answer against what you've written as the unknown quantity. For example, here we were looking for quarters, so we would expect our answer to give us quarters and not to give this what it has given us. So we will stop here for this video, and in the next video we will be looking at deriving conversion factors.